Okay, so today what we're going to be doing is talking about problem solving with the normal distribution. Okay, and that makes us happy. And you can see over here I have the TI calculator available, and that's what we're going to be using today to help us figure out what's going on, right? So excellent. So let's go ahead and get started. We're only doing one example today because the content's pretty easy. And so the objective is to solve applied problems involving normal distribution. Okay, and so I'm going to have a particular setup. We're going to use a calculator, and we're going to do it that way. All right. So according to the Department of Health and Education, cholesterol levels are normally distributed. So this is kind of an important thing to note in a problem as you read through it. That allows you to do that. For men between the ages of 18 and 24 years old, the mean is 178.1 and the standard deviation is 40.7. Right? So what percentage of men in this age range have cholesterol levels less than 239.15? Okay? So what we're doing is we have the mean, and that's going to be 178.1. We have our standard deviation of the population is 40.7, and we have a score of 239.15. Okay? And so what we're going to do is we're going to take this information and we're going to convert it to a z-score, and with that z-score we'll be able to figure out what the percentage of men in this age range have cholesterol levels less than that specified amount. All right. Now, the z-score is given by the value minus the mean divided by the standard deviation. Okay. So if I'm going to plug into this, it's going to be 239.15 minus 178.1. All right, look, too small. It's too small. All right. So here's what we're going to do. We're going to go over to the other page. Oh, let's see. Oh, I don't have it. All right. So we are going to go over to the new slide, right? And so now I just want to calculate the z-score. And all right, and the z-score, if we look, is the 239.15, right? So we've got 239.15 minus the mean score. The mean score is 178.1. And that's all going to be divided by the standard deviation, and the standard deviation is 40.7, right? So we've got 40.7. Now, I'm not going to do this by hand. Of course, that's what I have the calculator for. So parentheses 239.15. And now this is really important to have this in parentheses, otherwise your orders of operations are going to be really screwed up. All right, so don't forget the parentheses. Right, and we're going to divide by 40.7, and we're going to end up with a z-score of 1.5. Now, if it had been 1 or 2, we could use the empirical rule here, but it's 1.5, right? So what we need to do, and these are what percentage of men have cholesterol less than 239.15, right? And so a nice thing to do here is to sketch the picture. A picture is worth 1,000 words, right? So if I sketch this picture right here and I draw the normal curve, right? And in here I've got my 178.1, right? And here's one standard deviation, here's 2 standard deviations, here's 3 standard deviations. I'm just going to go left and right, okay? And so now he's at 1.5, all right? This is the values that I'm looking at. So right here in between 1 and 2 standard deviations, a z-score of 1.5. I'm looking for values less than that. So I'm going this way, right, all the way down to the end. all the way down to, well, if this is negative 1, right? If this is negative 1.1 as a z-score, and this is negative 2 as a z-score, this is negative 3 as a z-score, and this just keeps going, right? Man, this could go a really long way. So how far could it go? Well, the rule of thumb that we like to use is to go to negative 100, okay? If you're using the calculator for the calculator. If you're using a z-table, this is a completely different process, okay? But for the calculator, this is what we're going to use. And then the function that we're going to use is the Normal Cdf Function. And what you want to do is you want to put the leftmost z-score in, and here we've chosen it to be the arbitrary negative 100 because we're just getting far enough to the left that the area between the curve and the x-axis is essentially 0. And then we're going to go all the way to the right to the far one, and that's the 1.5. And so I'm going to have the 1.5 in there, and I'm going to plug this into my calculator. Now, so I'm going to go over to the calculator. Okay, so we're going over to the calculator over here. And the normal function, it's a normal distribution. So I'm using the distribution function. And if you look, Normal CDF is the second one. And basically what this does is it calculates the area under the curve. It's the cumulative density function. Cumulative density function. And so it accumulates all of the area underneath the curve between two z-scores. So the lower z-score is like negative 100. Okay, the upper z-score is going to be 1.5. And now the mu and the sigma, okay, this is what messes students up. All right, this is in terms of z-scores. Okay, this is in terms of z-scores is what we're doing. And what is the z-score in the middle? The z-score in the middle, the mu is 0. Okay, and then what is the standard deviation for z-score? Well, the standard deviation is always 1, right? I've gone from negative 1 to positive 1. The standard deviation is always 1. So mu is 0. That's the z-score for the center. And the standard deviation for z-scores is 1. So those guys are just fine, and I'm going to hit enter. Okay? And now yours may look a little bit different depending upon which operating system you're using and whether your stat wizard is on or not, okay? But it's Normal CDF, it's the left and then the right, okay? I'm sorry, I'm just trying to let it get caught up. And then normally you would just close it up, okay? And hit enter, depending upon whether your stat wizard is on or not. And so the area then underneath the curve is 0.9332 to 4 decimal places. Okay, and so if that's the probability, then the percentage is just convert that number to a percent, and that's 93.32%. Now, note, this may be off a little, okay, from a table or what you might see in the back of the book or something like that, because sometimes you have to do some estimating when you use a table. Sometimes they don't use negative 100. They might use something else. I think my calculator defaults to like negative 1 times e to the 99 or something like that, or 1 times e to the negative 99, something like that. And so in this last decimal place, you may get a little bit of difference, but it's only going to be off a little. As long as the first 3 numbers are the same, you're probably good to go, and I'm hoping your professor wouldn't mark off for that. I certainly will not mark off for that. Okay? So that's that example. All right? Now another example is, let us go ahead and find the amount of time that self-employed Americans work each week is normally distributed. Again, this is really important, with a mean of 44.6. All right, so I'm going to have a mean of 44.6, okay, and a standard deviation of 14.4 hours, right? So my standard deviation is 14.4 hours. All right, and we want to find who works between that many hours per week. And so now I have an X of 37.4 at the lower end, and I have an X of 80.6 at the upper end. Okay? And so, again, I'm going to calculate two z-scores. Right? So the z-score is going to be equal to the 37.4 minus 44.6 divided by 14.4. And these numbers are coming from the equation in the previous slide. All right? And the other z-score is going to be 80.6 minus 44.6, all divided by 14.4. All right? And so I come over here to my handy dandy calculator. Right? Come over here to my handy dandy calculator. And so with parentheses, I'm going to have 37.4 minus 44.6, close it up, divided by 14.4, and hit enter. Okay, so it's negative 0.5. Okay, and then we're going to go parentheses 80.6 minus 44.6, close it up, divided by 14.4, and we're going to end up with 2.5. Right, so 2.5 standard deviations above. All right, now remember, picture is worth 1,000 words. Okay, so I'm going to draw my graph. Right, here's my center, and so there's 0. Okay, and remember, I'm going negative. So here's negative 1 as a z-score. Here's negative 2 as a z-score. Here's negative 3 as a z-score. Here is positive 1, positive 2, positive 3. Okay? And now negative 0.5 is going to be here. Okay? And 2.5 is going to be here. And so I'm looking at all of this area right here. So if I had to guess, well, not that, right? All this area right here. Now, I'm a little bit to the left, okay? And I'm not quite to the end. It's kind of like I'm shifted over. So I'm thinking this is going to be approximately 50%. Something close to that. Probably a little over, but probably pretty close to that, okay? So I want you to think about these kinds of things, and this is why we draw the picture, all right? Now, I am going to use my normal CDF function, okay? I'm going to go from negative 0.5, that's the left-hand side, my negative 0.5, to 2.5. That's my right-hand side over here, and this is going to give me the area in between. So I go second, vars, 2, right? And it's negative 0.5, enter. The upper is 2.5, enter. And of course the mu is 0, because look, mu is 0 here in the middle. And the standard deviation is 1. Look, it's 1, 2, 3, right? Negative 1, negative 2. So the standard deviation is 1, because these are z-scores. So rarely are these going to change unless you're not using z-scores. All right? I'm going to paste those in. Now again, yours may not have the 0, 1. It may not have that screen. You may just type it in just like how it looks right here. But no matter whether you have the stat wizard or the old operating system, when you hit enter, you should get 0.6853, and so that's going to correspond to a percentage of 68.53% of hours will be between, right? What were they? Let's go back and look, because I forgot. Oh, my pen's messing things up. 37 and 80, right? So between 37.4 and 6. They were right here. Okay. So this percentage of hours will between those, and that makes us happy. All right, well, this video is already over 15 minutes long. Hopefully this really helps you out with using the calculator to do this instead of a table. My parting shot would be, if your professor is making you use a table, the calculator is a great way to check what you're doing on problems that you're doing at home and stuff, to make sure that you're using the table correctly, right? But train like you fight. So if you have to use a table, make sure you're using the table for your homework and you're only using the calculator to check your work. All right, thank you and have a great day.